Alright guys, so this is just going to be a quick video on the last two example problems of the 18-2, 18-3 unit circle and trig notes. I'm just going to assume you already know your unit circle very well, so I won't go over anything up top. Anyway, let's just get started. He uses bike wheels with 30 inches in diameter, so we'll probably just start by using the 15 inches because that comes in handy in a second for radius. So let's just remember 1 radius length equals 15. All right, and we know his delivery tires rotate at 140 revs per minute. So what is his angular speed in radians per minute and linear speed in miles per hour? All right, so if you have any science classes, you know what dimensional analysis is, so we're going to use that here. 1 revolution on the bottom is equal to 2 pi radians. So we're going to get 280 pi rads per minute because these cancel out. And that's the first half. Done. All right. So to convert from angular speed into linear speed, we're going to have V equals R times the angular speed, which is W. So if we think about it like this, one radian is equal to 1 radius length. So if this arc length is 15 inches, this angle is 1 radian. That means for 2 pi radians, we go around the whole circle. That means if we multiply 2 pi times the radius, that is equal to the circumference, which if we take the circumference equation equals 2d, this is true. We find it to be 2 pi times r, which is completely right. So just to show you that checks out. So that's why we're going to multiply the length of the radius times the angular speed in radians per minute in order to find the linear speed. So if we do this now, we're going to get V equals 15 inches times the angular speed, which is 280 pi, and rads, I should note, is a unitless measurement per minute. But remember, we want this in miles per hour, so we're going to do some more dimensional analysis, and that's going to give us 60 minutes in an hour times 12 inches in a foot times 5,280 feet in a mile. And this gives us 3.98 as our linear speed. And this is in miles per hour once again. It should be noted that this value does not match what is on Mr. McGow's answer key. And you'll notice that it's exactly half. And that's because when he plugs in radius, he accidentally puts 30 inches. So yeah, his answer key is slightly wrong, but that's okay. Anyway, next problem. A thread is being pulled off a spool at a rate of 75 centimeters per second. Find the radius of the spool if it makes 110 revolutions per minute. Okay, so we're just looking for radius here, which is nice. So if it makes 110 revolutions per minute, we should probably write that down. And it also tells us our linear speed, which is nice. It gives us a linear speed or velocity of 75 centimeters per second, which is nice. All right, we're also going to go back to this equation. This is equal to r times angular speed. And we're told the angular speed is 110 revs per minute times 2 pi to get radians. So that's going to be 220 pi per minute. All right, and obviously we're going to want this in seconds. So let's convert it over to seconds, which is going to be 1 minute has 60 seconds. So if we just do our calculating, we're going to get 11 over 3 pi radians per second. All right, that's nice. And then obviously we need to find the radius. So we're going to have 75 centimeters per second equal r times 11 pi over 3 per second. Multiply both sides by seconds. This cancels out. And then we're going to move all of this to this side. So we're going to have 75 cm over 11 pi times 3 equals r. And if we solve, we're going to get that r equals, divide by 11, and then divide by pi again, 6.51 centimeters. And this one does match the answer key, so he's right here. All right, thank you everybody. I will see you next time.